In many of the Gracie Academy videos, I have to expand a expression of the form a plus or minus b to the n, and I tend to be able to expand it by inspection very quickly, and a lot of people have asked me, am I just working this out beforehand and writing it down while I do the video, or am I working it out as I go along? And in actual fact, I'm working it out as I go along, and it's very easy with this relatively simple trick. So just looking briefly at the traditional way, let's say for example you wanted to expand a plus b to the power of 7 or whatever. The traditional way that you would learn is you would do a plus b times a plus b, and you'd work out the answer to that, and then you'd multiply that answer by a plus b, and then you'd work out the answer to that, and you'd multiply that by a plus b, and you would get the right answer. If you had a spare half an hour in an exam, well, it's probably something that you could do, but I certainly wouldn't recommend it. There's a much easier way. So let's have a look at that. So in theory, you might think there are 4 possibilities: a plus b to the n, a minus b to the n, minus a plus b to the n, and minus a minus b to the n. But in actual fact, all of these are 1 and a bit methods, because minus a minus b to the n, we can take minus 1 to the power of n out, leaving us with a plus b to the n, and that becomes exactly the same method as that. And a minus b and minus a plus b, we could just flip b and a around so that we had b as the positive term here, which would be the same as the positive term here, and we could use that method. And in actual fact, when we work out a minus b to the n, we will use the same method as a plus b to the n, and then just do a tiny little adjustment at the end. So in actual fact, there is only one method to learn. So let's get going, and the first thing we need to look at is Pascal's triangle. So Pascal's triangle, you start with 1, and then you keep putting 1 on the other side. Then all you do is you add the number. So 1 plus 1 is 2, and that is for n equals 2, and that will mean something in a minute. For n equals 3, we go 1. 1 plus 2 is 3. 2 plus 1 is 3. 1. For n equals 4, we got 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And I would definitely recommend that you learn Pascal's triangle at least up to maybe n equals 7. You use it so often, or I certainly use it so often. That's 1, 6, 5 out of 10, 15, 10 out of 10, 20, 15, 6, 1, and let's just go up to n equals 7, 1, 7, 21, 35, 35, 21, 7, 1. Okay, so there's Pascal's triangle, and that's what we're going to use to help us expand a plus b to the n. So what we're going to do, and it's probably easier to do an example, but what I'll just do is explain it basically first. So we have a plus b to the power of n, and what we are going to do is it's going to be a to the power of n plus the second number of whatever n is. So if n was 6, if n was 6, for example, it would be 6, for example. So it would be whatever the number is on the Pascal triangle, the second number here. Drop a by 1 power and introduce b. And then it would be plus whatever the next number is on the relevant thing, times a to the n minus 2b squared, add all the way until you get to a to the 1, b to the n minus 1, and then right at the end you have b to the n. Now the only thing you would then do if it was a minus b instead of a plus b is that every other term you would replace the plus with a minus, and that is it, and you've got, and hey presto, you have your expansion. Easiest thing to do, probably haven't explained that very well. Let's just expand something. Let's expand something here using the Pascal triangle n equals 7. So let's expand something which at first glance looks relatively complicated. Let's expand, for example, 2p plus q to the power of 7. Okay, so all we're going to do, so that's going to be 2p, which is our first term. Here's our first term here, 2p, and here's the second term, q. And because there's a plus, we don't even have to worry about the plus and minuses. We know everything's going to be a plus. So it's going to be 2p to the power of 7 times the first of the n equals 7 terms, which is 1. Add the second term is, in the Pascal's triangle, is 7, and that will be then times 2p to the 6 q, and then it will be add the next term, 21, 2p to the 5 q squared, add 35 times 2p to the 4 q cubed, add 35. All I'm doing is I'm going along this line here, the Pascal's triangle, the relative line, I am dropping the power of this term by 1, and I'm increasing the power of this term by 1 as we go along. So we're at 2p to the, oh sorry, that's 2p to the 4 cubed. Add 35 times 2p cubed q to the 4, add, and we're here, 21, 2p squared q to the 5, add 7 times 2p to the power of 1 now, q to the 6, and then finally add 1, because the last term is 1, q to the 7. And then all we would have to do is just tidy this up here. So 2p plus q to the power of 7 would be, okay, so let's have a look at the first term here, 2p to the 7, well that's 2 to the power of 7p to the 7, and then we got add 7 times 2 to the 6 p to the 6 q, add 21 times 2 to the 5 p to the 5 q squared, add, I'm just moving along here, so now we're on this one, 35 times 2 to the 4 p to the 4 q cubed, add 35, we're onto this one now, here, 35 times 2 cubed p cubed q to the 4, add 21 times 2 squared p squared q to the 5, add 7 times 2p times q to the 6, add q to the 7. And that's the answer. I mean, we can go further and actually do the numerical calculations, but they're relatively easy. 21 times 2 to the 5, 35 times 2 to the 4, etc., etc., etc. Now, if it was 2p minus q instead of 2p plus q, all we would do is just change the sign of every alternate term. So that one would be a minus, that's a plus. That one would be a minus, that's a plus. This one here would be a minus, that's a plus. And this one here would be a minus. So it is child's play. If we can work out a plus b to the power of n, it is child's play working out a minus b to the power of n. I'll just give one more example, because at the moment on the Grassy Academy YouTube channel, we're doing a lot of de Moivre theorem, where we are ending up with expressions such as z plus 1 over z, for example, to the power of 8, which is commonly found in de Moivre. And again, if we just look at the Pascal's triangle, I've only done it to n equals 7, so let's just do it to n equals 8. That would be, hang on a sec, 1, 8. So Pascal triangle would be 1, 8, 28, oops, sorry, 28, 56, sorry, 28, 56, 70, 56, 28, 8, 1. 1, 2, 3, 4, 5, 6, 7, 8. Yep, so that would be, so that is the Pascal's triangle for n equals 8, and I got that just by adding n equals 7, so 1 add 7 is 8, 7 add 21 is 28, 21 add 35 is 56, etc., etc. And you can actually see that it is symmetrical, so you only need to actually calculate the first half, and the second half is identical. So now we can expand z plus 1 over z to the power of 8. We can expand that by inspection, just by using exactly the same formula. So that would be z, which is this one, plus 8 z to the power of 8, I've got it wrong already, so z to the power of 8, because n is 8, z to the power of 8 plus 8z to the 7 times 1 over z, because that's the second term, 1 over z, and that's the first term z, add 28z to the 6 times 1 over z squared, and you can literally write it, so you're not even having to calculate it, you're just writing it down. Z to the 5 times 1 over z cubed, add 70, z to the 4 times 1 over z to the 4, add 56, z cubed times 1 over z to the 5, add 28, sorry, let's put it on the other line, sorry. So in actual fact, there is no time needed to z squared times 1 over z 6, add 8z times 1 over z 7, add 1 over z to the 8. Add 1 over z to the 8. 1 over z to the 8. And again, if we were doing z minus 1 over z, which is also very common in de Moivre's theorem, all we would then need to do is just change the sign plus to minus on every alternate term. And that's it. So that's how you can save yourself a huge amount of time in exams by expanding out these brackets, just remembering Pascal's triangle and this one simple method.